Good morning students, I am Vetri Chelvi from Vetri and Vetri Neet Chemistry. Before going to the videos, I request the students to subscribe. If the viewers are new, please subscribe my channel, which is containing 82 high content of the videos which explains the previous year questions of Aims and what is called Neet exams. Okay, kindly please use my videos and give the comment and the views for better improvement of my channel. Let us go to the topic. Today's topic is optical isomerism. Okay, let us see. We know what is the condition for optical isomerism. The compound should contain asymmetric carbon. Now we are coming to the question. How many stereoisomers do the molecule have? Okay, now the molecule is there. They are asking stereoisomer. Let us see the stereoisomer means which should contain geometrical isomer and then optical isomer. That meaning what I said, the arrangement of the atom different in the space. Okay, now let us write the molecule which is having the formula is CH3, CH double bond CH and then CH2, C, H, Br and CH3. This is the structure they are asking. Here what is the difference is, this is you are having double bond. So this represents cis-trans isomerism. What is the formula to find out the cis-trans isomerism is 2 to the power of n. Here n is the number of double bond. We can go call it as a unsaturation. So 2 to the power 1 is equal to 2. What is this is the number of cis-trans isomerism. Otherwise we can call it as a geometrical isomerism. And then we are moving to here the asymmetry carbon of this is which is connected with the 4 different groups. It is containing asymmetry carbon is 1. So for that the formula is number of optical isomer is equal to to 2 to the power of n. What is n is the number of chiral carbon. Here it is 1. So 2 power 1 is equal to 2. So now we are having optical isomerism 2, geometrical isomerism 2, both together total isomer is 4. Option should be the number 4. You are having the answer is here. So now the answer is B. So like that you are having definite question is there. Okay, now we are moving to the next question. Which of the given is optically active? Is the question is Aims 2010. Okay, now it is provided. If it is a yesterday video, I gave everything the linear molecule. Here today I am giving the little bit advanced of the closed ring structure. Okay, in the ring structure optically active, the same condition for optical active means you want only the always it is the chiral carbon or we can call it as a asymmetry carbon. That is simple. Rule is same only. Here we can find out this carbon, this molecule, this is CH2, CH2 is not available, but this OH and this OH exactly opposite. So it is not having asymmetric carbon. How we can find out is this OH, here after 2 carbon OH, here also after 2 carbon OH. That means what? Both sides are same. So this carbon is not asymmetric. Like the same condition for this is also. In this category what is available is H and H. So these 4 carbon straight knowledge not asymmetric. This is because of the both sides are same, so it is not asymmetric. So this molecule is not answering. Now coming to here, this OH, here in this understand knowledge is here hydrogen. Here also hydrogen. Now this diagram represents carbon with OH hydrogen. Here carbon ring with 1, 2, 3, 4 everything CH2, CH2. In this side if you are coming mean the carbon which attached with the methyl group. So what is the knowledge is this carbon is asymmetric. Again repeating, 1 OH, Number 2 is hydrogen. Number 3 is this carbon which is having methyl substituted. This is carbon, but it is the long CH2. So carbon follow the group you have to see. Here carbon follow the group. So both are carbon, but the groups are different. So this carbon is asymmetric. The same knowledge, with that I am completing this carbon. Coming to this carbon, same one hydrogen, one methyl group. So this side if you are coming in carbon with OH. This side we are coming in carbon with CH2. So this carbon also asymmetric. So now the question is, which of the following is optically active? So B is optically active. Next you go and see here, all are having H2 not. In this case of carbon, you are having hydrogen. So now you are having the other, this is one carbon, this is one carbon. If you are coming this direction, it is CH2. If you are coming this direction, also CH2. So these are same. So this is not asymmetric. Now coming to this is the same, like this same condition. So here also the same CH2. So this compound also not having asymmetric. So which is optically active means this is only optically active. What we can say advanced means this time. Here asymmetric carbon is 2. They can have how many optical isomers? Like that means you have to go to the 2 power 2 is equal to 4 optical isomers. Okay, now this is in advanced question I am giving. Now let us go to the additional information. Now let us go to the next question. Okay, find the number of stereoisomers of 1,2-dihydroxy cyclopentane Aiims 11. Stereoisomers of optical and geometrical isomers of 1,2-dihydroxy cyclopentane. Now let us draw the cyclopentane. This is your cyclopentane and they are asking to give 1,2-dihydroxy. Suppose I am giving carbon number 1 hydrogen means this is carbon number 2 hydrogen. So now this compound you can call it as a 1,2-dihydroxy pentane. Then what we can watch it, that is the plane of symmetry is there. And then what about the carbon is, this carbon you can call it as a chiral carbon. This is chiral. How means this point you are having one hydrogen. Two groups are different. Here with the CH it is going on. Here carbon with the OH. So this is asymmetric. Already I told the knowledge in the previous question. So same knowledge apply. Here also one hydrogen. 2 and here carbon with OH, here carbon with the hydrogen. So this carbon also you are having asymmetric. Okay, now what is the two condition you have to take it in the mind. Here this tabulation for the formula is written for exclusively for you. Please copy down and find it in the important notes. Okay, now let us see the formula. If the condition is symmetrical and n is equal to even number, which is applicable for this question. Symmetrical, number of chiral carbon is 2. So what is the optically active isomer? That meaning is D and L they are asking mean n to the power of minus 1. Okay, let me write here the formula. I will work it out. 2 to the power of n minus 1, that is equal to n is the number of chiral atom. You are having 2. 2 minus 1, that is 1, to 2 power 1 is equal to, this is number of optical active isomer D and the L. Okay, then mesoisomer mean what is the formula is that for this is I am working to this 2 to the power of n by 2, 2 by 2, that is 1, 1 minus 1, it is 0. 2 to the power of 0 is equal to 1. What is this is number of mesoisomer. Suppose they are asking how many D and L isomer? 2, which is optically active. How much mesoisomer? 1, which is isomer, but it is not optically active. Question final, next column you can see total number of optical isomer, that is addition of this and this, that is 2 plus 1 is equal to 3. So what is this is DL and isomer optically active. This is meso optically inactive. What is total is 3. So in the question they are asking the number of stereo isomer. So my answer is 3. Option is here. So you should be very careful about the word. Number of how many optically active isomers? Suppose the question means the answer is 2. How many mesoisomer question is? Answer is 1. How many stereoisomer or other word optical isomer mean? That is this question is 3. Okay, so you should be very clear about this knowledge. Now let us coming to the very simple question. This is which of the given compound are optically active? Okay, now here we can see at a glance. Okay, what is the point I want to draw is here the molecule, if you are putting here mean this is called plane of symmetry, POS, plane of symmetry, which divide the molecule in the 2 equal half and both are the object mirror image. This is called it as a meso compound. So because of this plane of symmetry, this is not optically active. So it is clear. Okay, next coming to here, you put this here mean you are having 2 equal R, but they are not object mirror image. So this is, you imagine children, this is the imaginary line, plane of symmetry line I am putting, but the upper one top of is not the mirror image of bottom. Here F is there, I is there, I is there, F is there. What I can say, here there is no plane of symmetry. So since there is no plane of symmetry, we can expect this is optically active. So small tick. Next coming to this is, here same you draw the imaginary line of plane of symmetry and the top and the bottom are not mirror image. Here I, here F and I. So there is no plane of symmetry. So it is optically active. So this is also optically active. Here let us draw the imaginary line and what we are watching is both top and bottom are the exact object mirror image. I with I, F with H. So this is labeled as meso compound. So that is called optically inactive. So now we have identified optically active is B and C. Go on to find out the option B, C. So now this is your answer. Like that we have to approach the question. Prepare well children. Thank you.